In this video, I am going to cover the 9th program of data structure, that is to design, develop and implement a program in C for the following operations on singly circular linked list with header nodes. Represent and evaluate a polynomial p of x, y, z, which is equal to 6x square y square z minus 4yz to the power 5. So here are these numbers are powers of x, y, z respectively. So next 3x cube y z, 2xy power 5, and then z 2xy power 5z minus 2xyz power 3. So these are the powers. Now here in this video I am going to just explain how to represent and evaluate a polynomial, and then in the next video I am going to find the sum of two polynomials, poly1 and poly2. That is, you have to read two polynomials and you have to store the resultant polynomial in the polynomial, store the result of the polynomial. Let's first understand how exactly we are going to perform the polynomial representation, that is using singly circular linked list with header nodes. That we'll see in this video, as I'm going to explain only representation of a evaluate, how we are going to read a polynomial. That I'm going to explain in this video. Now, for example, if the polynomial is of this form, 6x square y z plus 3x y and z plus 4, okay, and whereas in this term x power y power z power are zeros. Now we have to see how we have to represent in terms of circular header list. Circular list is what? Where the last node in the linked list is pointing back to the first node, okay. But when it comes to circular header list, you have something called header node in the beginning of the linked list. This is one header node, and that header node is a special node in which normally contains some special information, like maintaining the information of a linked list, or sometimes it does not have any purpose, just to indicate it is the header node, and that is actually pointing to the first node of the linked list, okay. So this is how the circular header list look like, and the last node is pointing to the header node. This is how the program circular header looks like. So where header node, as I said, contains sometimes special information, or sometimes just some dummy values we are going to insert into that. Now let's see how this polynomial can be represented in the form of circular header list. So that's why first we need to create one header node. Next, here as I said, these fields, that is each term in the polynomial contains three fields, which are those: the coefficient, x power, y power and z power. So now here in the header node, the structure would be the same as these kind of nodes. Okay, that's why these fields are initialized with -1, and the name of this node I am going to name it as, name of this header node is head. Now the link part of, as usual, even this is a node of a linked list, so it will have a link field, and that link field is pointing back to itself. When a head link is pointing to head, when a head's link is equal to head, then it means that circular header list is empty. Circular header list is empty. Now, I want to represent this polynomial. That's why I have created a header node. Next, I have to create a node for each of these terms. Let me show you all now how this polynomial is represented using a circular header list. First, as usual, I have to create a header node, and header node is initialized with some dummy values here, that is -1, because the node structure is same as the other node structure of the polynomial. Other node structure contains the 4 fields, that is coefficient, x exponent, y powers and z powers. So all these are the 4 fields. Apart from that, since it is a node, it need to have one link field. So any node contains the 4 fields as I just told, x, y, z powers and then link field. So here also same, these portions are initialized with -1, and then the link is pointing to this. Now regarding the polynomial that is represented, that first I have to create a node for this, represent coefficient 2 x powers, y power, z power. Okay, that value I have represented, and then what I have to do, this is your newly created node for this. Now we have to attach, this link should point to here, and its link, that is newly created node's link, should point back to the first node, as it is a last node. Now another node we need to create for this term of the polynomial, that is 3, 1, 1, 1, and finally this link need to be joined here, and this need to be here. Next, for this 4 also, what is the powers of x, y, z here? X power is 0, y power is 0, z power is 0. So attach that coefficient 0, 0, 0, and then attach back here. So this is how each polynomial need to be represented. Okay, that the representation or reading this polynomial in this way, let us see the program. So how we can implement that with the program. So first of all, you need to include the header files. stdio.h, stdio.h underscore extension.h. This is for to access file structure internals, like IOStream buffer. If you want to deal with that, then you can use, it is to access file structure internals. As I said, it is to access all the deal with the IO buffers. In that case, you can use. Next, stdlib, already we have discussed, math.h we have already discussed, and now our aim is to create a node structure. So name is struct node, then the fields are coefficient, powers, x, y, z, all these are integer. Then you know that every node will have the link field of the data type struct node, and since it is holds the address, it need to be of pointer type. Now here, instead of every time using struct to node star, I will name that, alias that as node. So instead of calling this as any more struct node star, then I will, or to represent the address struct node pointer, I will use the name node. Okay. First, let's see how to create a node or how to allocate a memory. That's why I have created here a small function which will get a node for me, which will allocate a node for me. That's why I will declare the variable x and then allocate a memory and whose size is of struct node. And after that, allocating memory, malloc is always returns the starting address. So that is held by x and that will be returned. Okay. Now read polynomial. So I have already explained with the example how exactly it is going to perform. Now I am going to create a variable that is needed for me in the program, temp, head and current. Okay, as well as choice, whether after reading each term or after reading each term by the user, if he or she or user, if he wants to continue further, add some more terms. So that is given as a choice. You can see here, do while ch equal to y. If a user says yes, then he will this particular portion of the program will create one more node. Okay, if a moment he says, he or she, that is user says no, then he is going to then the program is going to return the starting address of the polynomial. Okay. Now, as I said, let's take the same example what we have created just now. What was the example? 6x square yz plus 3xyz square yz plus 3xyz plus 4. No, for this, as I told first, we have to represent in a circular header list. The circular header list have one head node, and that's why we have to call a get node function. Okay, the address allocated, the starting address will be assigned to head. Okay, now what this field also contains this that is filled even this is a node. So the field we have coefficient field, x field, y field and z field as well as link field. We should tell what is this each of these containing. So when it comes to the coefficient field, I said already it will be -1. We don't store any special information here. So though it is a special node, we just initialize with the -1, just indicate the beginning of the circular header list. This head is just indicated in the beginning of the header list. And then since it is just the beginning, head link should point to head. So that means you are saying that right now circular header list, that is polynomial circular header list, is empty. Then let us go on adding the nodes for it. So that's why I will create one call get node function. So again I will call get node function. Structure is, as you know, it is same. Okay. Then I will enter the fields, that is 6211. 6211. So and the name of this node is temp. Okay. Now we should make a link from here to here and the last node should point back to head. So first I will assign head link point to temp. Head link will be pointing to temp and the temp link will be pointing to head. This change I am going to make. Okay. So once you make these changes, earlier connection will be lost. This is what I am going to do every time whenever I am going to add a new node. So that is that connection. You can see here that connection I have shown here. In this case, current link equal to temp and temp link equal to head. But what are all these? So you know that that many a times in the circular head there may be more than one or more node. In that case, you have to identify the last node and attach the newly created node to the last node. So to identify the last node, okay, in the circular header list, we are using this program. Now let's see how this portion is going to work. Okay, we have to, as I said, we are going to identify the last node in the circular list. That is why we are using this particular program. Okay, suppose there is no nodes in the list, then current is initialized to head, and directly current will be equal to, current is initialized to head, and current link will be equal to temp link will be equal to head. That we are going to do. If suppose there are more than one node in the list, let me take one more node and then I will show you how we can attach the last node. 3, 1, 1, 1. Okay, now the last node is pointing here. Now we have only one more node to create according to this polynomial. So now I will create one node, temp equal to get node, temp equal to get node. After that I will enter the relevant details of the term 4000, and then current will be equal to head. Current starts from the head. Okay, and then current link, whether it is not equal to head, current link, whether it is not, when it is equal to head means what? When you say that current link is equal to head, means there are no nodes in the list. When you say that current link not equal to head, means there is at least one node in the list. But here in this case there are more than one. So current link is not equal to head. Okay. So what you do? Current, make it to point to the current link. So make it to point to the current link. Now again, current's link is not equal to head. Whether current link is pointing to head? No, current link is pointing to the next node. So make current point to current's link. Current's link is pointing to the next node. Make this. Okay. Now again let's check whether current's link, whether it is pointing to head. Current link portion, whether it is pointing to head. Yes, this time current link is pointing to head. If so, what happens? While loop terminates and directly this line will not execute. You are jumping to this portion. This portion is linking portion. So current link should point to temp, and the temp link, okay, temp link should point to head. This, when you make this changes, earlier connection will be lost. So this is about the read polynomial. Now every time you can see that it is asking, do you want to enter more coefficient? This will be asked after reading each term. It is going to ask you whether you want to read more coefficient. So now, why this underscore? Please note there is double underscore f purge std in. So in case of the buffer, if some unnecessary characters are left, if you want to discard those unnecessary characters from the standard input buffer, and then you want to read a character, then you have to write in this manner. If you want to discard the pending data, I can say discard pending data from the input buffer, then we can use f underscore f purge std in. Okay, so as I told, if you say yes, more number of terms will be read and you can attach to the circular header list. Moment you say no, that means after entering the last term, I will say no. Then what happens? The do while loop terminates and it is going to return the starting address. Starting address normally is by the held by the starting address is by the head, variable head. Okay, suppose if this particular node's address is 100, then that value will be written. This is about read polynomial. Next, about some polynomial addition we'll see in the next video.